Okay, so today's theory lesson will be Unit 3.2 output devices, Unit 3.3 storage devices, and Unit 3.4 the motherboard. Unit 3.2 output devices. So what is an output device? An output device is basically any device that can take data on a computer and make it available to a user. Okay. Anyway, like a monitor, a screen, it basically takes the data, shows it to you so that you can interpret it, in this case visually. Can also be speakers or earphones, which then will be audible output. And then output devices can also be divided in a few categories. Like I said, display devices, which you would see is basically the monitors or screens. They can come in LCD or LED. Then we've got printers. So printers basically, as we know, just transfer the data on a page and then we can also again see it. You get a few different types of printers that we'll discuss. So the first one is an inkjet, then we get an ink tank, a laser, or a 3D printer. The next category is data projectors. So data projectors is basically like in class if we put the display onto the overhead projector and we can see it on the whiteboard. Okay. The HDMI and VGA that stands there, that's just basically means of connecting the projector to the computer or laptop or whatever you're connecting to it. Then the next one we have speakers. So that is basically our audible output devices. So that can range anywhere from earphones, in-earphones, speakers, etc. Yeah, I think that's about all. Okay, so we're gonna now just go a bit more and dive deeper into these categories and explain them a bit nicer. Okay, so display devices such as monitors, it's basically, like I said, it's just a visual interpretation of data. And if we look at monitors, they have actually important characteristics. Okay, one characteristic is the number of pixels. Okay, so a pixel is basically, if you look very closely at a screen, you will see like a little tiny dot of color, and that is basically called a pixel. Okay, pixels that are put together then basically creates a whole image or a picture. Okay, the more pixels the screen have, obviously the more detail a picture can be. And then it just says, okay, so if we think about full HD, which is 1920 by 1080, then it means basically that's the amount of pixels. So you get something that's like 720 by can't remember the last part, but that's just basically the amount of pixels that is. So the first one is a cross, so it's your width, and the next one, or the second one after the times, is normally your height. So the 1920 pixels mean there is 1920 pixels across my screen from left to right, and then up and down it is basically 1080 pixels. So basically if you times those two together, you get something, you get all the pixels that is currently on the screen. Okay, so that's just basically pixels and what that refers to. The next one is screen size. Okay, so the screen size is basically, it's measured diagonally, so from one, let's say, left bottom to the upper right, or the upper left to the bottom right. Okay, this size is then measured in inches to give the size. Okay, then we've got refresh rate. So refresh rate just means how quickly the monitor can update its image to display new information. Okay, the speed there is normally measured in hertz, as we see here, Hz, which stands for hertz. Okay, then we've got contrast ratio. So contrast ratio is basically the measurement between the blackest black and the whitest white a screen can show. Okay, then we've got aspect ratio. So this is basically the shape of the screen. That just means it's kind of like the width to the height that is measured in inches, and then we display it just in a ratio. So for an example, let's say my screen is 16 inches wide and 10 inches tall, or the width, then basically the aspect ratio will be 16 to 10. Okay, so this just basically shows you, like I said, the shape of your screen. If you add 10 to 10, that means it's a perfect square monitor, and then obviously here we can see my length is a bit bigger than my width of my screen. Okay, next one is the brightness. So brightness is just basically the perception of how intense the bright can go. So normally on a laptop you would just adjust your brightness. So if it's nighttime you would put it a bit lower, and if it's daytime you would put it up a bit. Normally we don't really adjust it on the computer, but some screens obviously have the function. If you look at the menu part of your screen, you will see there is like a brighter or dimmer setting on your monitor. Okay, then printers. Okay, printers, like we said, it just gives an output on a paper. The main types of printers are the dot matrix printer. So what a dot matrix printer is, it's basically a printer that has a lot of small pins that strike a ribbon coated with ink. Okay, so then that ink just transfers to the paper. So we don't really use dot matrix printers anymore for home printing. Where you would most likely see dot matrix printers are at like till slips that are like punched with those. It's not going through, but it just strikes against the paper to create the text, whatever you want to portray on the page. The next one is inkjet printers. So an inkjet printer, basically the key is it sprays the ink. Okay, so hundreds of tiny nozzles spray drops of inks directly onto the paper while it is moving across it, and then basically that is just how the ink gets transferred to the paper. So it has nozzles that sprays the ink. Okay, next one is a laser printer. So a laser printer basically uses electrostatic technology by prepping the page, and then it basically pours the toner, which gets drawn by that magnetic or magnetized page then, and then it sticks onto wherever the page was magnetized. Okay, then it basically goes through a roller, and that toner is then just melted onto the page. So with that, it also, the drum basically also applies pressure to that page, so that is then how it is heated and again using pressure bonded to the page. Okay, that's why normally you will feel laser printers, as soon as they come out of the printer, it's normally like a hot or a warm printer that gets printed. Okay, the next one is an ink tank printer. You don't really have to worry much about this one, but it's just basically I would say a lot of we have one at home. It's just your printer has like printing heads. Okay, and then your printing heads has like an ink tank above it, so it just constantly feeds it ink as it needs, and then again just moves across the page and print basically onto it. It's easy. If you run out of ink, you normally get like refills that you can just refill your ink cartridges with. Okay, next one is a 3D printer. Okay, so that's just the last printer. So a 3D printer basically takes something on a software, a design, and then it can actually print it to make it a solid object. Okay, normally plastic is melted onto like a platform using a robotic arm to basically print whatever you designed. Okay, so it basically starts at a base and then just melts layer for layer for layer for layer onto your base plate, and that layers then actually build up into a solid object. Okay, with printers, there's also factors, just like monitors, to consider. Two of these are the DPI, or the dots per inch. What that means is, in 1 inch, how many dots a printer can print. Okay, so the higher the DPI, obviously the more detailed the prints. It's almost like pixels. How many pixels are in the screen? So this is just basically how many dots can the printer print in 1 inch. So the more DPI, with the more pixels, the more details the screen, and then with printers the prints are. Next we've got ppm, which stands for the pages per minute. Okay, and that just, okay, this is in black text printers. Okay, so if all the text are black, it's measured to see how many pages can that printer print in 1 minute. Okay, obviously the higher the ppm, the faster the printer prints. Okay, then we get to data projectors. Okay, so what are data projectors? Projectors use a bright light to project content of a computer or a device onto any flat surface. Okay, mostly we like a white background because that just gives us more detail. Yes, I think that's all really to say. We would find like decent printers is, like I said, at school we use it in class, and if you want to see like a high-end projector, you would actually, if you go to the movies or the cinemas, then they use like a very high-end projector to show the movies on that screens. Okay, here's the VGA and HDMI. So that's basically just means of connecting the projector to your device. So VGA is used for an analog video only connection, whereas HDMI is used for a digital video and an audio connection. Okay, so most of your new projectors actually comes with small speakers. It's weak, and it's really not good, but actually it can actually also serve as speakers if you don't have anything else. Okay, then sorry, I'm still live, right? Yes. Okay, then what is the advantages of projectors? So they are actually very easy to carry around. They're very lightweight, as opposed to like the old projectors that they used, where it had like a lamp and mirrors to display. Some of you might know it from primary school, those huge bulky projectors. So this is where this new data projectors are actually cool. They are very lightweight, very easy to carry around, and obviously if you've got a small screen and you just data projects something, you get a much more bigger size display. Okay, disadvantages of this data projectors is replacing the lamps is very expensive. If you buy low quality projectors, the images can be seen as faded or washed out or really not good quality. As well as low brightness projectors also needs to be placed quite close to a wall or a screen, and that obviously decreases the size of the image. Okay, then you can just read through lumens and stuff, but speakers and headphones. Okay, so as I said, we know what a speakers and headphones is. It's basically just when data's or it is not when, it is used when data is actually transferred into something or an output that can be audibly heard. Okay, so what is the advantage of speakers? So obviously we know that they can be used to listen to music. If, okay, let's say in a computer, then if you get an email, it can alert you, okay, listen, there is an email that just came in, so it can notify the users. Also, text can be converted into sound. Okay, so if you are visually impaired, then the speaker can actually help to give feedback from your device to your ears, and then you can have a better idea of what's going on. Okay, obviously then there should be disadvantages as well. So the disadvantages of computer speakers is, okay, so this is not of speakers in general, this is just of computer speakers, and that is just they are quite actually large and they take up a lot of space on a desk compared to just using headphones. Okay, so here's just a quick view of all the types of headphones you get. So you get a closed back headphones. It just basically creates an isolated audio experience that only you can hear the sound you want to hear. Okay, so then we've got in-ear headphones, so it's mostly your phone earphones. So they are very portable, versatile and convenient. You can just throw it in your pocket and go. And they also go a bit more deeply into your ear, so to provide comfort, sound isolation and sound accuracy. Another one is Bluetooth headphones. So it's basically a device using radio transmitter technology, or RF, to send the signals, well, from your device to the headphones without any wires. Okay, so that you can listen to sound. Then we've got input and output devices. Okay, so this is where input, or the device has an input and an output capability. Okay, so they are capable of sending data as an output to a computer and receiving data from a computer, which is then an input. Okay, an example of this would be, so in some classes we've got only a overhead or a projector, a data projector with a whiteboard that you need to write on with normal markers, so that won't be seen as an input-output device. But as soon as you talk of an interactive whiteboard, you will see some classes have a data projector that, or not even, you get like just a big, if it's a big screen that is basically a touchscreen, then obviously that is an input and an output, because it gives a display and you can write on it to give feedback to the computer. Okay, so then activity 3.2 you must just complete, and then we move on to unit 3.3, which is storage devices. Okay, so storage devices also basically have the same purpose, and that is to store data. Okay. Okay, then obviously you get a lot of different storage devices, and they differ in capacity, which means how much data they can hold, the portability, the speed, and then just there's a lot of reasons. Okay, so some of these reasons you get the storage devices, or why they differ, is the function. So it determines if you need an SSD or HDD. I'll explain what that is in a second. You get storage capacity, so how big of a drive do you want in your computer. You've got portability, do you want to carry it around or not. You've got the use. So what is the use going to be? Is it going to be for just transferring files or installing an operating system, etc.? Then you've got volatility. Okay, so if you say something is volatile, it means as soon as the power goes off or you turn the device off, then it will clear whatever was inside it. So you will lose everything that it is basically busy with. Okay, so then we've got reliability and durability. Okay, so that is just basically how likely is it that the device will break. So if we look at the first one, types of storage devices. So if we look at a hard disk drive or a HDD, so a computer disk drive is a secondary storage device first off, and then basically a HDD has a magnetic platters that spins at a high volume or high speed, and you've got this, if you can look on the picture, it's this black metal part over here. It's called your read-write head. Okay, so that thing then just goes across the platter and read magnetic, or the magnetic drives, which contains zeros and ones, and then basically it can then either read from the disk or it can write to the disk, and then that is basically how this HDD holds data for longer than, okay, well, RAM, I'll get to RAM now, but yeah. So it's just basically mechanical drive that uses moving parts and magnetic platters to store data. Then we get external hard drives. Okay, so an external or a portable hard drive is basically just used outside of the computer case. Okay, so your hard drive it's basically just this very small type of very portable hard drive, you normally in a case that you can just plug into your computer via USB and then use it as a hard drive. Okay, then we've got a solid state drive. So a solid state drive, or an SSD, uses so it does not have any moving parts first off, so it's completely electronical, which makes it very, very superior in speed compared to the HDD. Okay, so a SSD uses special floating gate transistors to store data electronically. Okay, so like I said, because it's electronic and a HDD is mechanical, the SSD is very, very faster, but if you look at price wise, an SSD would be more expensive per gig than a hard drive disk. Okay, then you can read through these other memory types. They're not very, very important right now. One that are optical discs. Okay, so optical discs refer to a CD, DVD or Blu-ray discs. Okay, and they basically just use light to either burn onto a disk or read from a disk. Okay, then next up is activity 3.3. You just need to complete this for me, and then we are at unit 3.4, which is the motherboard. Okay, so a computer's motherboard is basically a large printed circuit board that physically connects all the different components together. Okay, so this includes the CPU, GPU, RAM and so forth, and it also acts as a device that supplies everything with power. So all that components that are then connected to the motherboard gets distributed with power. Okay. The functions of a motherboard basically to connect everything together, to distribute power, and allows communication between the components. Then we get to processing devices. So these are just the devices that goes onto the motherboard basically. We've got the CPU, or the central processing unit, and that is just the part of the computer that are responsible for receiving and carrying out computer instructions, or in other words the processing. Okay, each CPU can be made up of multiple cores. Okay, here they speak about multi-threading versus multi-processing. I'll get to that in a second, but by adding multiple cores to a CPU, the processing power available to the computer can increase. Okay, so normally you can't really add cores to your CPU. You need to go buy the CPU with many cores, or however you want, or it's gonna suit your needs. But yes, a CPU with multiple cores onto it, and a core is basically an independent processing small unit onto that CPU, obviously. That processors are then called multi-core processors. Okay, the CPU contains a control unit, or a CU, that coordinates all activities in the CPU, basically, which controls it, and an arithmetic logic unit, or an ALU, and that is basically just where all the logic operations and arithmetic calculations are carried out. Excuse me. Then we've got the GPU, which is the graphics processing unit. Okay, so the graphics processing unit, or the GPU, is located on plug-in cards on the motherboard, so it uses the slots on the motherboard. Okay, it says here slot for GPU over here, so the PCI Express slots. Okay, so it uses the PCI Express slots. You can put a GPU into those slots to add an external GPU. Otherwise, the chip is basically in the CPU if you use onboard graphics, and that is basically responsible for creating and doing calculations needed to display images on the screen. Next up, we've got memory. So a random access memory, or RAM, is basically physical hardware that temporarily saves data it is currently busy with. RAM provides space for your computer to read and write data to be accessed by the CPU. And here it says RAM is volatile, so it means if the power goes out, or it does not receive any more electricity, you turn the device off, all data inside it are lost. Okay. There's a few ports you can just go read through. And then next up would be activity 3.4, ranging from question 3.4.1 to 3.4.5. Okay, so not the rest. And that is all for this theory lesson.